All right, so what we have here is the next page of 1.1, and it is about understanding equations. On the previous page, we went through last time, just as a quick little review, and we did some definitions here that you should definitely know, and labeling, and then also plotting of points. Now we're going to start to get a little more complicated here. We're going to start talking about equations. I filled this page out ahead of time just for time's sake. An equation, essentially, the main thing you're looking for is an equal sign. So it's a statement that tells about the relationship between two values, and they can either be true or false. All right, but again, one of the key things to look for, it's an equation, therefore equal sign. All right, and then solutions to equations of two variables are ordered pairs. That satisfy the equation, where you plug the first one in for x and the second one in for y, and it turns out that the two sides are equal. So let's take a quick look right here at this example. It says determine whether the given point is a solution for the given equation. So by noting the order of my ordered pair, this first one is x, the second one is y, which is what I went ahead and wrote here, x and y. And so now that I know what x and y is, I can go back to the original equation right here and plug them in. I plugged in 0 for y and 0 for x. When I do that, I end up with 0 on the left-hand side and 4 on the right-hand side. Therefore, those are not equivalent. This is a false statement, and therefore, this is not a solution. Now, when you're doing this, after you plug values in, you're pretty much going to want to only work on one side at a time. You're not going to want to do the old algebra rules where you say, well, if I do it to one side, I can do it to both sides, kind of a thing. You're not going to want to, subtract something from both sides and mess with it. You're going to mostly want to work on one side and completely reduce it down to a number, and then work on the other side totally independent of each other. The reason for that is like what I drew right here. If you had something that said 2 equals 3, we know that is false, but what I can do is if I do it to one side, I do it to both, I multiply them both by 0, I get 0 equals 0, therefore this is true. You want to avoid making some sort of mistake like that, and sometimes you don't even realize when you make a mistake like that because it gets kind of complicated in there. So just be sure to only work on one side at a time. All right, let's take a look at the next example here. This is determine if 3 negative 5 is a solution to the equation y equals 4 minus x squared. Again, this tells us that x is 3 and y is negative 5. So we're going to plug those in to the actual equation. Be very careful when plugging in negative numbers. So I plug in negative 5. I put parentheses around everything I plug in just to be safe. So negative 5 just stays negative 5. On the right-hand side, I plug in 3 for x. 3 squared is 9. And then I get 4 minus 9, which is negative 5. Negative 5, that is true. And therefore, yes, that is a solution. All right, the very last one here is to determine if negative 1 is a solution to the equation y equals 4 minus x squared. So both of them are negative 1 in this case, so we're going to plug in negative 1 for both of them. Here I plug in the negative 1 for y on the left-hand side, which just stays negative 1. On the right-hand side, I'm very careful that I plug in negative 1 like this. Because if you look over here, negative 1 squared is different than the quantity negative 1 squared. All right, they are not the same thing. This one means the negative of 1 squared. All right, this other one means negative 1 squared. So those are two different things. On the left side, it would be 1 times 1, and then you take the negative, and you get a result of negative 1. On the right-hand side, it's negative 1 times negative 1, and therefore is just 1, and they do not equal each other. So be very careful when you plug stuff in, especially stuff that has negative signs. Make sure you're putting parentheses around it and applying whatever square or cube or anything like that that's happening to it, to the whole thing. So we end up with negative 1 times negative 1, that's 1. 4 minus 1 is 3, and negative 1 does not equal 3. This is false, therefore this is not a solution. All right, so that's it for this page. Let me pause it real quick and take any questions. All right, so moving on to the next page, we basically have graphing equations by plotting points. What we're going to do here is simply just kind of brute force our way into figuring out what the graph of an equation looks like. Later on, we'll get more, we'll get fancier about doing this. But at this point, what we're really going to do is just kind of pick a few points, plug them in, and see what ordered pairs we get. So we're going to pick x values. The x value in the equation here is called the independent variable. So we can pick pretty much whatever values we want for the x values, and then what will happen is we will plug them in and we will figure out what the corresponding y value is, and the y value is called the dependent variable. So we pick the independent variable, and then independent variable, and then y will depend. Is it ENT or ANT? I can't remember. I'm not a great speller. It'll be the dependent variable. It depends on what independent variable you pick. So we can go ahead and plug this 3 in, and we will get y equals, and we'll get 3 squared minus 2 times 3 plus 4. And if we do that all together, 3 squared, I can do this in another, 3 squared is a 9, 2 times 3 is a 6, and so we end up with 9 minus 6 plus 4, and that ultimately gives us a 7. So we end up with the ordered pair 3, 7, like that. We can come over here to the graph, and we can find the point 3, 7. That's 3 out in the x direction, and then up 7 in the y direction, like that. And therefore, we put our point right there, and there's the first point of our graph. Now we can keep going. We can try the number 2. We plug that in. Y equals 2 squared minus 2 times 2 plus 4. And that's 2 squared is 4. 2 times 2 is 4, so we have a 4 minus 4, so that's gone. And so we just end up with this last 4 right there. And so this is just a 4. And so therefore we have the ordered pair 2, 4. So we come over here, we go over 2 in the x direction, up 4, so over 2, up 4, and we end up right there. And we can put a point right there. There's our second point. The next one is plugging in the number 1, so we do 1 squared minus 2 times 1 plus 4 equals 1 squared is 1 minus 2 times 1. So that's 1 minus 2. That's a negative 1 plus 4. That's a 3. So this is the point 1, 3. So I go over to 1 and go up to 3, and there's my next point. So already this is not a straight line because these points are not in a straight line with each other. If we draw a straight line through any of the 2 of them, it only hits 2 of them. So we automatically know this is something curved. So let's try 0. Y equals 0 squared minus 2 times 0 plus 4. Well, 0 squared is 0. 2 times 0 is 0. So that's a 0, that's a 0, and we just have the 4. And so we end up with the point 0, 4. There's our ordered pair. And so we go to 0 and just go straight up to 4. And we put a point right there. And we have the point 0, 4. I'm going to do just one more here, and we'll have the basic shape. We should see it. We'll do negative 1. Y equals negative 1 squared minus 2 times negative 1 plus 4. Now be careful here. This negative 1 squared is a 1 because it's negative 1 times negative 1. Here we have minus 2 times negative 1. That becomes a plus 2. And then we still have that plus 4. So we ended up with all positive numbers there. 1 plus 2 plus 4 is 7. And so we get the ordered pair negative 1, 7. And so we come over here to negative 1, go up to 7, and we're right there. And so at this point, hopefully this is a kind of graph that you recognize, a parabola, and we can simply draw in our nice kind of U-shaped curve. It's not a V down there at the bottom. It's smooth. And there we go. We have our graph. So what I'd like you to do now is I want you to pick a couple of points and try this one real quick and see if you can get it. I think I'd like to change the number on there from 2. Let's make this a, let's change it. Change it in your notes too. I don't want to do a 2 there. Let's do a 4. Let's put a 4 there. So make it 4 minus x squared. And do that one. All right, so give that one a try. And then in a moment, I'll come back and I'll sketch it real quick and show you what it actually looks like. All right, so for this one, I'm not going to go through and put in a bunch of points, but you could pick points like you could try 2. Let me do that back. You could try 2, 1, 0, 1, -1, -2, stuff like that. That's going to get you right around it. I know what this graph looks like, and it's going to look like this. It's going to be an upside down parabola like that. So if you got something that looks like that from your points, then you did a good job. So like I think this would have been 2, 0. This would have been 1, 3. This would have been 0, 4. This would have been -1, 3, and this would have been -2, 0, like that. So hopefully if you tried those points, you got values like that, and you ended up with a graph like that. Okay, moving on to the next page. This is about identifying x-intercepts and y-intercepts. And remember, x-intercepts from what we defined the other day is, or on the first page, is where it crosses this x-axis. So we're looking at where does it cross the x-axis, that one right there, the horizontal axis. And when we look at this one, we see that it has one spot that it crosses it. It's right there, since it's a vertical line. And therefore, the x-intercepts, you could write it as just the place where it crosses it, which is at -3. Or, and you should especially be able to recognize this, you might write it as -3, 0. You need to be able to recognize both of those as answers for it. For y-intercepts, we're looking at when does it cross this vertical axis? And the answer for this one is it does not. It doesn't cross it anywhere. And so therefore, we have none for y-intercepts. When we look at this next one here, we can look for x-intercepts. Again, we have none. It's not crossing that axis anywhere. And therefore, we have none. It's a horizontal line. Where does it cross the y-axis? And the answer is right there in that one little highlighted spot. And so we can count that 1, 2, 3, 4. That's at y equals 4 or 0, 4, like that. Okay? So what I want you to do is take a moment and find me all of the y and x intercepts for the next two before I come back and fill it out for you. So take a moment and do that. All right, so that's it for 1.1. Be sure you check your answers here on those last ones on this last page. And we're going to go ahead and start section 1.2 now. This is linear equations and rational equations. And so we'll start off with a linear equation. So a linear equation in one variable is an equation that can be written in the form ax plus b equals 0, where a and b are real numbers and a does not equal 0. This immediately tells us that we have something, essentially if we were graphing this out, if we change that y, that 0 to a y, this would be the equation of a straight line. And so that's why they're called linear. They are of the form of a line. So let's go ahead and try some of these, and we're going to solve and check and see if these are linear equations. So we look at the first one, and we're going to go ahead and just solve it, and then we're going to check and make sure that the answer we got works. So in order to solve this, I'm going to add 14 to both sides, and I'll end up with 7x equals 14. I am then going to divide both sides by 7, and I'll get x equals 14 divided by 7 is 2. So there we got our answer, and now we want to just do a quick check by plugging it back in and seeing if it works. So we're going to plug in 7 times 2 minus 14 and see if that equals 0. So we're just checking it like before. So 7 times 2 is 14. We have 14 minus 14. We end up with 0 minus 0. There we go. We can check that off. That one works. The next one, we're going to want to go through and actually do some distributions and try and solve for x. So the first thing we want to do is actually just distribute everything through our parentheses so that we can get x by itself. So I'm going to multiply my 2 into both terms in the parentheses. That'll give me 2x minus 6. And then I keep the minus 16. And then I have 13 minus 3. So I'm going to multiply the negative 3 into both terms inside the parentheses. So I get negative 3x. And then I get negative 3 times 2, which is negative 6. So that's what I end up with right there. I'm going to start combining like terms, try and get all the x's on one side and all of the just regular numbers on the other side. So I have here 2x, negative 6 minus 16 is negative 22. Over here I have a 13 and a minus 6, and 13 minus 6 is 7, and then a minus 3x. Now I'm going to try and get all the x's on the left-hand side and all the numbers, the other numbers on the right-hand side. So I'm going to add 3x to both sides. So plus 3x over here. And then after I do that, I'll end up with a 5x minus 22 equals 7. And now what I'm going to do is add 22 to both sides. And I get 5x equals 7 plus 22 is 29. Please tell me if you noticed me make a mistake or anything on this. I expected this to work out a little nicer. I didn't mess anything up there. 3x, 3x, 22. Yep, this is good. And then I'm going to divide everything by 5. And I'll come over here because I was running out of space. And I get x equals 29 over 29 over 5. The next step would be to plug that back in and make sure it works by doing a check. And once you do that, you'll know that you have it right. So I'm going to pause this right now because I want you to try a couple of these next ones and see how you do. All right, so you may find that some of these you have x canceling out or other stuff going on. The way you answer that is by looking at what we have right here. We have these 3 main types of equations. The first is called conditional. The second is called inconsistent. All right. And the third is called an identity. All right. So if we have an equation that is true for all real numbers, all right, that is called an identity. That's the identity one. Okay, so we can cross that off our list. Basically, this is going to occur when x cancels and the statement you have left and what you have left is true. So say x cancels out totally and you end up with 3 equals 3. Now suddenly that is an identity. It doesn't matter what number you plug in for x, that equation that you started with holds true for all of them because the x canceled out and it didn't matter, but it was still true. The next type that you can have here, it says, is it's an equation that is not an identity, but it is true for at least one number. That is conditional. In fact, I might just copy this. That is a conditional one. Okay? So that's conditional. That means that it's like this one up here. This one is conditional. Because we solved it, we had at least one, there could be more than one, but we had at least one solution where it works. So that equation, the 7x minus 14 equals 0, is true on the condition that x is equal to 2. It's not true for every value of x. It's true under that condition that x equals 2. The last one that we can have then by default is this one is inconsistent. All right, this is when an equation is not true, not even for a single number. This is when x cancels out but what is left is false. All right, it's false. Up here is when it was true, and then conditional, you had at least one true, you found at least one solution that made it be true. It could have been 2 or 3 or 4 or whatever, but there's at least one that shows it to be true. Okay, so let me pause this again and take. All right, so like I said, finish up these ones, check them with the answers in the back, and let me know if you just cannot get any of them figured out. But again, be willing to struggle with them. That's when you do your best learning. So let's take a look here at linear equations with fractions. So for this one, what we're going to try to do is we are going to try to solve this and get x isolated, but we're starting with different fractions. And the first thing we're going to want to do is eliminate those fractions. And we're going to do that by finding, right here, by finding the smallest number divisible by every denominator. All right, and then we're going to multiply everything by it. So if I look at this one, I have a 4 and a 3. The least common denominator, the LCD, the least common denominator for 3 and 4 is you start looking for the smallest number they can both go into. They both can't go into 3. They both can't go into 4. They both can't go into 6. They both can't go into 8. They both can't go into 9. I'm looking at just multiples of each one of them. Then 12 is the next multiple. That's a multiple of 3, and it's also a multiple of 4. So the least common denominator is 12. Now, if you happen to be doing one of these, and let's say you missed 12 and you kept going until you got to 24 and you didn't realize 12, you didn't notice 12, that's fine. It's still going to work out for you doing this as long as it's a common denominator of both of them or all of them. All right, you're good. It's just simplest to use the smallest one. But don't be worried if you end up with a common denominator that's not the least one, it's still going to work. And you can always just find it by multiplying all the denominators together. It just may not be the simplest way to do it. So since that's our least common denominator, what we're going to do then is take that 12. All right, we're going to take this 12 and we're going to multiply everything by it. So we end up with 12 times x plus 2 over 4 minus 12 times x minus 1 over 3 equals 12 times 2 is 24. At this point, I would go through and just start reducing. I have 12 divided by 4. So I would do that and get a 3 times x plus 2. Over here, I have negative 12 divided by 3. That's a minus 4 times x minus 1 equals 24. And now at that point, this is fully solved to the point where we're just doing what we were doing before, which is distributing 3x plus 6. That's distributing the 3 through. And then we're going to distribute the negative 4 through. That gives us a minus 4x. And then a negative 4 times negative 1 is a positive 4 equals 24. I'm going to try and group everything that's like together. So I'll have 3x minus 4x. That gives me a minus x. And then I have 6 plus 4. That's a plus 10 equals 24. And then from here, I'm going to subtract 10 from both sides like that. And I get negative x equals 24 minus 10 is 14. And now the last thing I have to do is I have negative x. I want positive x. So I'm going to multiply both sides by -1 to get rid of that negative sign. All right. And so then just coming right over here, that gives me x equals negative 14, like that. Okay. And so you would then go back, especially on a test. I didn't think I wrote that very well. You then go back and plug it into the original equation, make sure it works, and check it. Here we happen to have the answers at the back. I don't remember what number was that? I think it was it 15? I hope so, because that was -4. No, it's number 7. So let's look at number 7. There we go, -14. There we go, we got that answer. We matched up with there, but you would want to plug that back in and check it. So I'm going to just tell you the least common denominator for this next one. You would try that and you should get that it's a 6. For the other ones, I'll let you figure it out. This one might be a little tricky, but see if you can come up with one that is, again, if you get in trouble, you could always just use a common denominator. It doesn't have to be the least one, and do 4 times 14 times 7 and make that whole thing your common denominator. All right. After that, it's just some additional practice problems doing these same things you can try. And so what I want you to do is go ahead and spend the rest of this time working on these and seeing what you can get figured out. Okay. And then check your answers at the end and let me know if there are any issues. All right. So